I have a sample protocol here that uses a very simple translation to demonstrate how this can work. So I'm going to open my translation protocol, and translations are always located in the protocol settings. They have their own tab. As you can see, we have two translations defined for this particular protocol. I'm going to go ahead and open the first one so we can take a look at the available options. We have three settings here. I'm going to open the mode. As you see, the mode defines whether this translation is for received data, sent data, or both. So this allows you to control which direction OmniServer is going to translate data for, whether it's data that OmniServer is sending to a device or data we're receiving from the device, or both. The computer field is where you're going to define data as it should be seen by OmniServer. So if this happened to be a send translation, then the computer value here would be the pre-translation data, as in the data before we're going to apply the translation to it and send it to the device. If this was a received translation, then the computer value would be the post-translation data, would be the data that we received from the device and what we want to translate and send to a client application. The remote field defines data as it should be seen by the remote device. So if this is a send translation, this would be the post-translation data after OmniServer has applied a translation and sent it to the device. If this was a received translation, this would be the pre-translated raw data that we're receiving from the device before we apply the translation and pass that to the client. Here you can see this translation is for translating received data only. That means we're expecting to receive a hexadecimal 0 from our device, and when we receive that hexadecimal 0, I want to pass a string value of off to my client application. Okay, back in our main menu here, we see two other settings at the bottom. We can tell OmniServer that for any messages using translations that have error detection codes, that the error detection code should be computed using the data as OmniServer sees it, so that any translations used would not actually affect the EDC calculation or its resulting value. This can be disabled if you're performing a translation that's required by a device, and that protocol specifies that the error detection code should take this translation into account when performing the calculation. The other setting here allows you to specify whether or not OmniServer should default to using these translations for all data fields and all messages. If you do not enable this, then you do have to specify whether or not to use translations for each sequence in a message. This is disabled for our translations now, so we have to specify when a sequence is going to use these translations. Okay, I'm going to go and close out of this. I'm going to open my host message. And since this was a receive-only translation, we're just going to go over and take a look at the response section. So you can see here we have a data item defined with string formatting. And we've got this T+ here, and I'm going to explain that to you. And we're terminated by a carriage return. We're going to double-click on this item to open up the sequence builder. See here, like I said, the string formatting. If we move on to the advanced formatting, then you're going to notice this translation field. And you're going to notice we have a radio button for translate here. And you see that translate setting corresponds to our T+ up here. It's going to be this by default, which means that it's not going to translate. You can also tell your sequences specifically not to translate, which is actually really useful if you set the previous setting so that it defaults to translating everything that we saw when we were defining our translation. At that point, you can let it default to translating everything, and then you can specify sequences that you don't want to translate. If you have a lot of sequences that need to be translated, that might actually be the best option. In this case, we're going to leave this at translate, which tells OmniServer for any bytes that it should parse into this item, it needs to apply those translations. So basically, if a value of 0 is received, the word off is going to be passed to the client for this data item. If the value of 1 is received, then the word on is going to be passed to the client application for this item. Any other values other than that will be parsed as is because the translations won't apply. Okay, let's go ahead and close this protocol and I want to go take a look at our Modbus RTU protocol, since it's such a good example of both register and topic variable use. We're going to take a look at the registers first. The register number list here, we have 2 register numbers defined. Let's go ahead and open up the address register and have a look at its options. The name here is going to be used whenever you're referencing the register, whether it's in a message where the actual value is going to be placed, or when you're creating an item that's using the register. The range that's defined down here is 0 to 9,999, which means that any item that's using this register as part of its item name is going to end up basically being 10,000, having 10,000 instances of itself, all ending with the sequential number based on the range. And close this. If we go to our items list, notice all the items that are actually ending with the address closed in curly brackets. That's how you define an item that uses a register. You define whatever you want the textual part of the name to be, and then in curly brackets you put the name of the register you want to use. So for each one of these, like this AI for instance, that basically means that this is actually 10,000 items instead of just the one that you're seeing. For instance, if you browse the OmniServer with an OPC client for a topic that's using this protocol, you'd see AI0, AI1, AI2, and so on and so forth on up the range used by the register. Now let's go take a look at the read holding register's host message that we have that's using this register. Open that up. And in our request section here, notice that we have our address register that's defined here, and this is where the address offset needs to be in this particular request. So we have that field there so that whenever a client requests an item, let's say they request A01, then a 1 is going to replace this field in the sequence that gets sent out to the device. In the response section, notice we have our AO and then our address, where we have our register defined for the item, just as a normal item would be. Just because this one's using a register, it's still placed normally in a message as a normal item would be that wasn't using a register. The difference is that when a tag gets updated, the tag getting updated depends on the register number value that was passed to OmniServer when the client originally requested this item. If a client requested A01, then we're going to get this back, and this register is going to have a 1 in it, which means we're not going to take the value we get back from the device for this response and parse it to A02 or something like that. It's going to allow us to parse it to the correct item. That basically makes this host message variable so that it can request values for any holding register address. We'll go ahead and close this host message and take a look at the topic variables now. Expand our topic variable list. We see that there's a single topic variable defined. We'll go ahead and open the properties. We see that there really isn't a lot of configuration involved with the topic variable, other than the name, which is going to be used when you're referencing the topic variable in a message. And then you've got the description. Now this is what's going to be displayed in the variables field of the topic, where you're actually going to define the values for it. Go ahead and close that. Now if I go back to that same host message and open that up, notice in the request section that we have our topic variable defined here at the beginning of the request. Now, this is the location of the device ID in a typical Modbus request. So that means that whatever value we set for that variable to topic level is going to replace this variable here whenever we send the request. In the response section, notice we also have the topic variable defined here because a Modbus response also begins with the device ID. Okay, now I'm going to go ahead and close that. I want to go back to my configuration here, and I want to create a topic that's going to use that Modbus protocol. Let's call that Modbus, and we're going to define the Modbus R protocol, and we're just going to use COM1. Now you see, once I've selected this protocol, if I go to the Variables tab, notice that we now have a variable titled Station ID, which corresponds to the description field I just showed you in the topic variable in the protocol. Any value that I enter here is what's actually going to get sent in the host message request for the that are using the topic variable. And that's also going to be the value that OmniServer is looking for in a response to know that that response goes with this particular device. So if I put a 1 in here, then it's going to get passed to OmniServer in the host message using this, and that's going to be a Modbus node ID or station ID, device ID of 1. That's what's going to get passed. Go ahead and cancel out of this. Now that we've taken a look at those three features, I want to go back to our Modbus sample, bring that back up, and take a look at the error detection codes that are predefined, and also take a look at the error detection code builder. I'm going to go ahead and open this host message back up, and take a look at our request section. Notice that the sequence here at the end of our closed square bracket, this sequence just happens to be one of the predefined error detection codes available from the sequence builder that you can just select. They're already pre-configured. First of all, notice the square brackets, the closed square bracket here and the open square bracket here, are what define the actual data bytes that OmniServer should use in the calculation of this error detection code, which happens to be a CRC. So OmniServer is going to compute this CRC using all the values that fall within these square brackets. Let's go ahead and open Sequence Builder by double-clicking on our CRC here, and we'll take a look at the predefined error detection codes. We're going to click on our Change Assignment button, and the EDCs are always listed under the Others section. As you can see, there are a lot of predefined EDC error detection codes here. Unfortunately, we don't have enough time to cover each one of these. But I do want to show you how I typically start when I'm trying to determine if a predefined error detection code is going to work for a protocol. If you click the help button down here in this particular section, then you see that we get a specific section that addresses error detection code options. See, we've got predefined error detection codes here. We've also got a section on user-defined error detection codes. Now we're going to go ahead and click on that. As you see, we get a list. We get a section of the list of the different categories, which are primarily going to be checksums, CRCs, and LRCs. Now, each one of these individual sections has a list of each of those individual variations of this type of CRC, like all the different CRCs, all the different checksums, all the different LRCs. And it has a description of the calculation used for each of those, and any additional information you might need to understand how that particular EDC works. Now, any decent protocol documentation should explain the methods or calculations that are needed to generate a valid code for its particular protocol. So it's always helpful to find that section of the documentation that details that, and then come to this section of the help file and compare their description to the descriptions that are here, and see if you can match up what you need to use here for your protocol. At the very least, it's usually possible to determine if the error detection code for your protocol should be a checksum, a CRC, or an LRC. Go to the checksum section. A checksum in its basic form is a sum of the preceding bytes. Basically, you specify inside square brackets what bytes need to be used in a checksum. And any checksum calculation is just going to sum those values up. Now, the formatting is probably going to vary, but that's the basic operation that's going to happen. Any variations on that should be detailed or explained in a protocol documentation, so you'll have some idea of which variation to use. I'll go back. Let's go to the CRC section. Now, for a CRC, there's always going to be some polynomial involved. So if a protocol document's talking about polynomials in reference to some error detection code or thing of that nature, you can be sure that it's some form of CRC. If a polynomial is mentioned at all, like if you look here, you see there's a polynomial listed that's used for each one of these calculations. And basically, you would just need to find in your documentation The documentation should give you some sort of idea what polynomial needs to be used for its CRC. And hopefully that there's the predefined one. You can come in here, match up the polynomials, any initial values that are required, whether it's reflected or not, and find the predefined code, the CRC that's going to work for your protocol. We're just going to go to the LRC section. As it mentions up here, an LRC code is always going to use the exclusive or XOR math function in its calculation. So if a protocol document is mentioning XORing values at all for its error detection code, then you can guarantee it's going to be some sort of LRC variation, because that's really the only kind of error detection code that's going to use the XOR operation. Now, not being a math major myself, I will admit that determining an error detection code is difficult sometimes. And it isn't helped when you have incomplete documentation that doesn't necessarily provide a useful description of how its error detection code should be calculated. In ideal circumstances, documentation is going to provide some sort of sample request or response that's going to actually contain real data with a real error detection code value. Always in cases like these, I use trial and error with the real data from those samples to determine which error detection code in OmniServer is going to result with the correct value shown in the sample. Now, a little later, when I get into Diagnostic Tools, I'm going to show you a special test device that I use that makes this type of thing really easy to do a trial and error with raw data like this from an example. I'm going to go ahead and close our help file here and close out of Sequence Builder. I'm just going to go ahead. We want to address the custom error codes now. I'm going to go to our error detection code list, right-click, go to New. I want to create a new error detection code. Because let's say I've tried the predefined codes that might work, that I think might work based on the information I have, and they're not correct. You see here that the name is what's going to appear. Any of these that you create are still going to appear in the Others section of the Sequence Builder. So whatever name you specify here is what's going to show up in that list in the Sequence Builder in the Others section. Then here in the Algorithm section, we have to define the actual type of error code we're using. Now this would be the type of error detection code, whether it's a checksum or a CRC or an LRC, and what type that is. Depending on, and you're going to select this depending on whether the result should be 8 bits or 16 bits. If the individual byte values that OmniServer is pulling from the raw data stream, whether you're pulling it 8 bits at a time or 16 bits at a time, which is your accumulator. Basically, if you have an 8-bit accumulator, that means that OmniServer is grabbing the data for the calculation 8 bits at a time. For performance calculation, if it's 16 bits, then it's going to grab 16 bits of data at a time for each value it's using in the calculation. Now, if a CRC algorithm is selected, notice there's a polynomial field that's available here, where you'd enter that specific polynomial that your protocol documentation's hopefully given you that it needs for the calculation. Fetch style is what data increments OmniServer should use for the raw bytes pulled from the protocol for use in the calculation. This sort of goes hand in hand with what I was showing you up here with the accumulator. This is the fetch style. This defines what format the data is in as OmniServer is pulling it from the raw data. I know we always talk about hexadecimal, binary, decimal. Realistically, all those different formats can technically be the same thing. Like a decimal number has a hexadecimal version and a binary version, so on and so forth, and vice versa. This defines how OmniServer should look at the data as it's grabbing those bytes for use in the calculation. There's also a bias and an initial value field down here for any protocols with an error detection code that specifies using a bias value to be set against the calculation, or that's supposed to have an initial value to start with in the calculation. A lot of CRCs do have an initial value. We're going to move on to the filter section. I just got to give this a test name. Move on to our filter section, which offers the ability to filter out certain defined values or characters from the error detection calculation. Go to our drop down here. There are options for skipping specific bytes that you specify here, or even pairs of bytes. You can add a second bias value in addition to the one we saw in the general section, or you can even go so far as to ignore control characters, such as character turn, start of text, end of text, things of that nature. You can tell your error detection code to ignore those and only process non-control characters for the error detection calculation. Notice there's also a checkbox setting down here for restricting process to only valid characters based on the selected fetch type, which we would select back in the general section. For example, if our fetch type back in the general section was binary and we had this option checked, then any data being displayed as hex or decimal data is going to be ignored. OmniServer is going to ignore that for the purposes of the error detection code calculation. The next important section is the post-processor tab. If we go here, the post-processor allows us to define specific operations to be performed on the result of the EDC as selected with all the options in the general and the filter section. These post-processor operations are performed on that end result and give you the actual end value for the error detection code. Now, the error detection code builder allows you to have up to 3 post-processor operations for any error detection code. Well, we don't really have time to discuss each type of post-processor, but you can see some examples would be doing a 1's complement or a 2's complement, returning the code value that would be the modulo of the processed error detection code from before, and then some value that you specify here to use in that modulo calculation. Now, these are going to be used, again, protocol documentation should have some information about these types of operations that need to be used in order to result in the correct value. And these particular options allow for a lot of flexibility when you're dealing with those types of weird or complex error codes for protocols. Now, I mean, a lot of protocols out there just use standard checksums and standard CRCs, and you're not going to run into this issue. You're going to be able to use one of the predefined ones, but for those really weird ones out there that you come across from time to time, it may be necessary to go into here and play around with the error detection code builder to build your own. The truly hard part is finding enough information in the protocol documentation to determine what calculation is necessary. Understanding how hard determining an error detection code can be, I'm always happy to consult with someone or with any of you that are working with OmniServer. If you're trying to figure out what type of error detection code you need to use, I'm always happy to help and try to help you figure that out, just because I do know how hard it is to figure those out sometimes because of the documentation. Now that we've seen some of how error detection codes can be configured in OmniServer and what the predefined options are available, we'll take a look at a real protocol document and some of the things to look for there. Let me go ahead and close out of here, minimize my protocol. I've got my document here. I'm going to show you a protocol document here that's a good example of the information a protocol document should provide for enabling communications to a device. And it's going to have the types of things to look for in a protocol document that are needed for building an OmniServer protocol. The document we're looking at here is for an intercom system. Now, the first place I always like to look is in the table of contents, which we have here, assuming the document has a table of contents, to see if there's a section listed that has some sort of indication that it pertains to command or message formats or communication or something of that nature. You see here we've got a message packaging section that sounds like it might actually have something to do with what we're looking for. So we'll take a look at that in a second. Also, I see down here we have a section that has some examples in it. Now, I always love a protocol document that has examples in it because I've always found it to be the most useful way to determine the format for a protocol. Because this is actual real data that you could potentially get from a device or need to send to a device. So there's no guesswork involved. Now, if we go to the message packaging section, I'm just going to zoom in on that so you can see it a little better. It's a little small. Okay, if we go to the message packaging section, we can see that it's given us the following useful information. Here at the top, we have all the serial communications parameters that we need, such as baud rate, parity. These are the things that we define in a COM device in OmniServer for communications. Also, here in this table, we're shown the typical format of a conversation between a PC and this intercom system. Particularly, we've got a direction that's specified that tells us whether this particular section of command is going from OmniServer to the device or coming from the device to OmniServer. So we know if either of these is supposed to be a send or receive. And it's also nice they've got it color-coded so that we can easily tell the difference visually. Also, if you look over here, it has the actual exact hexadecimal values that are to be used. So we know this is hex. We know that if we were to look, we're going to cover this a little later, but we have a tool called the I/O monitor in OmniServer. We know that if we were to look in I/O monitor for this device, we should be seeing these exact hexadecimal characters get sent to the device. We also see that it's telling us that conversation should start with a DLE and an ENQ. We can sort of tell that this protocol has some handshaking where we've got to send an initialization and get an acknowledgement back from the device before we can actually send an actual command, which is this body of the message package right here. And we've got the actual command. It gives us a description of what each character is, tells us what the character should be. So a lot of really good data here. From all this information, we can see, like, we've got an end of text here. We can see that there's a clear terminating character, which tells me that OmniServer is not going to have any problem with this protocol, because it's terminated at the end. OmniServer is going to see that end of text and is going to be like, okay, I'm at the end of my message. I know where to stop, which OmniServer has to have in order to function. Also, if we notice this double asterisk section down here, it's giving us the details of the BCC or error detection code that we're looking for. Sometimes an error detection code is referred to as a BCC. With the BCC specifically, that's usually a type of LRC, which we can also see. It says take the XOR of the combined message, DLE, and ETX. So we got our DLE message and our ETX. So it's telling us which characters to use in the actual calculation, so we know where to put our square brackets in OmniServer. And because it's telling us that it's an XOR, since I know that XORs are used in LRCs, and I know that this protocol is going to use an LRC. And it's more than likely, based on the fact that there's no additional information, probably going to use the standard LRC that's predefined in OmniServer. Now I'd like to take a look at some of the examples. You can zoom in on those two because they're kind of small. If we take a look at the examples here, we're shown specific examples of the types of commands with actual values, including, if we look down here, we have this is actual raw data, an actual raw data example with a valid value for the LRC, the BCC. Which means that we could take this raw data and use that with the diagnostic tools that I'm going to show you later and determine whether or not we're using the correct LRC calculation. Overall, this is a good document because it lays out the exact format of the commands and responses for this device, and it gives us clear information about the error detection code to be used, and it provides good examples. You're not going to find a much better protocol document than this. If they could all be like this, then it'd be a lot easier to determine if a device could be used with OmniServer and how to do that. Now, what do you do if a good protocol document is not available? This is going to depend on whether or not this is a solicited protocol, which requires you to send commands, or if this is an unsolicited protocol, where the device will send you data automatically. If it is solicited, it might be possible to determine the command format if you have some existing software package that can communicate with the device. At that point, a lot of times it can be useful to use a utility like Portmon or Wireshark to capture the data being sent to the device by that application. And then you can take a look at that capture and see what the format is. And a lot of times you can actually determine from that what you need to use in OmniServer to communicate with the device. Now, if the protocol is unsolicited, you can use a utility like Hyperterminal possibly to receive a packet from the device, and you can usually, a lot of times from that, see the format of the data that you'd need to use in an unsolicited message in OmniServer. Now that we've taken a look at some of the things to look for in a protocol document, I want to cover the diagnostic tools I use to troubleshoot protocols in OmniServer. Go ahead and close this protocol. We're going to go to our Diagnostic section in our OmniServer configuration. You see we've got 4 sections here. Really 3 of these are what I use primarily for troubleshooting. 3 most important diagnostic tools for finding and correcting issues, and I'm going to give those to you in the order that I typically use them when I start troubleshooting something. The item values window is where I start, and I move on to the I/O monitor, and then lastly the logger. I'm just going to select the item values window here. If you notice, we've got a couple of folders here. We've got a folder named Echo and a folder named Test. These folders actually correspond to topics that we have configured here in OmniServer. And we have a status item. When a client application is not connected to OmniServer, then the status item and any topic variables are all that's going to show up here. So if you're ever looking at item values and all you see is a status item, or all you see is a status item, and if you have a topic variable that's listed, then you're not connected with the client application. Whenever you're connected with the client, whatever items you're connected to and requesting are going to show up in this list. And this is always the first thing that I check when I'm troubleshooting communications, because the most fundamental concept when using OmniServer is that nothing is going to happen if no client is connected and requesting data for at least one item. OmniServer will not communicate with the device unless a client is requesting for it to do so. This section is also useful for seeing the current values of a tag and making sure that your client is receiving the correct value. Any tags that are listed here, it's going to show you whether or not it's actually active in the client, or if the client has it deactivated, and what the actual current value is for that item, whether quality is good or not, the timestamp, things of that nature. So notice that for my test topic here, I only have the status item, which means there's no client connected to my OmniServer. I'm actually going to go ahead and bring up my OPC test client, which installs with OmniServer, and I'm going to make a connection to that topic. I've already got my OmniServer, automatically appears in the OPC servers list. I'm going to go ahead and connect, and you can see I'm connected. I need to go ahead and add a group, and then I'm going to be able to browse the address space in OmniServer. I expand down here, I see I have my test and my echo topic. I'm going to expand my test topic. And you see we've got several items to choose from here. I'm going to go ahead and select my integer read item, and I'm going to add that to my address space. And then I need to go ahead and subscribe to the item so that the test client will wait for callbacks from OmniServer when the value changes. Now I've done that. Notice there's no value down here, and I have a bad quality. If I go back to my item values, notice that I now have my integer read item, and it's active, but I have no value, and I still have bad quality. We know there's still a problem, but we have eliminated the connection between the client and OmniServer as being the problem, because we know the client's connected. We know that it's requesting at least one tag. So we know that it's not an issue of the connection between the client and the server. So my next step is always to go to the I/O monitor. The I/O monitor allows you to select your configured device from this drop-down menu, and it's going to display any data that's sent by OmniServer or received by OmniServer from the device. And the data is color-coded. If you see over here in our color key, data is color-coded to make it easier to interpret. Any data that OmniServer is sending, as in like a request part of a host message, is always going to be black. So if you have a solicited protocol that should be sending a command and there's no black data shown here, then you're not sending commands to your device and there's some other problem. All other data you're going to see in here is going to be data received by OmniServer, and the color of that data is going to determine the status of your protocol parsing the received data. If your received data is green, then your protocol is doing what it's supposed to, and all the received data matches your protocol. You should have a value for any tags being requested. If your data is anything other than green, there's an issue with the formatting used in the protocol. You see blue unknown data. Blue data is received data that has not been processed by OmniServer, which normally means that a response or received portion of a message in the protocol doesn't match the pattern of data that's being received. Now, blue data should always turn either magenta or red unless no more data is received, at which point it'll stay blue. Once the data turns magenta, that means that that's data that's been received, OmniServer's processed it, but in the processing, OmniServer wasn't able to match it to any response or received portions of messages in the protocol. This means there's at least one byte that doesn't match what is being received, or there is a byte that's missing, or there's an extra byte in the defined message. Now, if there's red data, that means that an error detection code check has failed, and there's an issue with the error detection code that's being used for the messages in the protocol. That means that the value that we received doesn't match up with the calculation we have selected in the protocol for that particular message. Now I'm going to go ahead and I'm going to select the random device from this drop-down list, and this is a test device. Now this is a device that can be used to test that it installs with OmniServer. There is a specific protocol that you have to use with this particular device called the client_test protocol. Now the combination of these two is basically used for simulating data for proofing client connectivity to OmniServer. Say you don't have a device to test with yet, and you want to go ahead and get your HMI set, make sure that it's connecting to OmniServer just fine. Use the client test protocol and device to go ahead and set up some connections and make sure that you're reading and everything just fine. Notice that our in the I/O monitor for this device is magenta. That we have no value and bad quality in the test in the item values window. So there's a problem with the protocol for the topic. How do we fix it? We need the actual data here in the I/O monitor to the format of the message in our protocol. Since I said we're using the client test, I need to go ahead and open that protocol. Go over here to my protocols, open the client test, and I do want to go ahead and keep up my I/O monitor while I'm doing that. You can go ahead and pause that so that it keeps it from scrolling. It makes it a little easier to view. We're going to go back over here. This protocol, if we look, has a single unsolicited message. I'm going to go ahead and open that and go to our received section. This particular unsolicited message is configured so that it expects the very first character it receives to be an asterisk, followed by the words tick count and an equal mark, and so on and so forth with the rest of the data string. Now, if I look back at my I/O monitor, just above here, if you notice, here's the tick count equal tick count, but notice out in front here, that's actually and any control characters show up as the ASCII value here. All this is ASCII on the right, so if you get a control character, it's just going to show up as a dot because it can't be represented in ASCII. That's 1, 2, 3, 4 characters over, so 1, 2, 3, 4. That's a 0A. Now I happen to know hexadecimal in the conversion, so I know that a 0A is a line feed. Which we've got down here, so it's not the asterisk that we're looking for. So basically, the data we're receiving from the random device doesn't have an asterisk at the beginning of it. So we need to change that difference in our actual message by deleting the asterisk. Now that should match what we're actually receiving, and OmniServer should be able to process it. We just need to apply that and click Save. Now if we go back over here and push play again, notice all of our data now is turning to green. And if we go back to our item values, see we've actually got a value for the item now, good quality. And we go back to our client and we see that we're also getting a value and good quality there. Now this is a simple demonstration, but the same principle can be applied to any protocol. It's just a matter of comparing the data received in the I/O monitor for your device and comparing each byte of that to the data format that's configured in your protocol until you find the difference there. It should be like byte for byte. The OmniServer protocol should be accounting byte for byte for what's actually being received, and if it's not, you'll see magenta data, and you have to account for that in order to get things to work. Now let's say that we had come to our I/O monitor, and there wasn't any data in here. It was completely blank, even though we're connected with our client application. We've got nothing in here. No sent data, no received data. Even though we confirmed the client connection's good, we're accessing an item. At that point, you're probably going to have some errors in the OmniServer logger. All new messages in the logger are logged towards the bottom, so you do have to scroll down. If a client is connected and there's no data in the I/O monitor, then OmniServer is likely having trouble connecting to the physical device for some reason. If it's a serial connection, there could be COM error issues, or you could be getting COM errors here. There could be a problem with the COM parameters configured in OmniServer. Like if it was an issue with parity, you get a COM error here that indicated there was an issue with parity, or the number of bits and things of that nature. You get an error here that would give you an indication of that, so you could fix it. If it's a WinSock connection, you're making an Ethernet connection, you're probably going to have some WinSock errors shown in here. WinSock errors, you can usually Google those and find out the exact meaning of those as defined by Microsoft. Common ones you'll find are that the remote device refused the connection for some reason. Maybe you're trying to access it on the wrong port, or maybe another application is already connected to it and it only allows one connection. Or maybe there's some network issues of something of that nature. If you're getting timeout errors here, that means OmniServer is connected to and has sent a message to the device, but we never received a response from the device in the timeout period defined in the OmniServer device configuration. Now that could mean that a number of things. Maybe our request format's not correct, so the device receives it and it's like, what's this? So I'm not going to respond to it because it doesn't know what the command is. Or maybe the device never received the message due to some issues with cabling or networking between OmniServer and the device. Maybe the device received the message, but there's an issue with the device itself that's keeping it from responding. Maybe there's some logic going on that's tied it up and it can't respond right now, or maybe there's just an issue with the device. Or simply the timeout setting in the device properties may not be high enough. That defaults to 3 seconds, but if you've got a really slow device, like maybe you got a 1200 baud device or something, then maybe even 3 seconds isn't a long enough time to give it to respond to you. So those are some of the issues you could be seeing if you're getting timeouts. At that point where you're getting these error messages, you'd want it to verify all your device settings are correct, and maybe even go so far as to check your cabling or even the device itself. You may even need to power cycle the device sometimes. I've seen problems like that before that were resolved by power cycling of the device. These are the major steps that I follow when I start troubleshooting an OmniServer communications issue. They help to eliminate potential problems and narrow things down so that you can determine what the actual problem is. You basically start from the client side and work your way down to the device until you determine where the fault is and why you're not communicating. There is one last thing I want to show you quickly. I mentioned the random test device and the client test protocol for testing client connectivity. I'm going to go back over to my devices. We also have another testing device, which is one I've been referring to, called the Echo device. When this device is used by a topic, any data sent by OmniServer, such as the request part of a host message, is going to be echoed back to OmniServer, and OmniServer is going to see that as received data. Now, this device can be a little tricky to use, but it does make it really easy to test out unsolicited messages or response sections of host messages if you do have a real sample data response. As an example, I used it to test the translation that we saw on the protocol earlier to make sure it was going to work correctly. I'm just going to go actually open that protocol, translation protocol. Notice in this host message, open this host message up and go to the request. This would represent when you're using the Echo device and you want to test something out. In the request section, you'd put the actual raw data sample that you have for the device that you'd expect to receive from a device. Now I've set this up with an item so that I can actually control what quote-unquote value that the device is sending. So I can write to that, and that'll be the value that gets sent. if I go to my response section, I've got my item in here that I want my value to be received into, and whatever's in the response message is what you would actually ultimately use in a protocol for communication with the device. This is the response message you want to test out and see if it's going to work. Now we go over here. Since my response is a write type, and whenever I write to this bit item here, that's going to trigger this request to get sent out. And since I'm going to be using this protocol with the echo device in my topic, then whatever I send here is going to get bounced back, and OmniServer is going to see that as received data and try to parse it against this response message. So I'll just go back over to my topics. I've got my echo topic here. Notice I've got the translation protocol and the echo device. Now I'm just going to go back to my test client. I'm going to disconnect, connect again. I want to connect to my echo topic. So I'm going to add a group. In my echo, I need to add my data item, which is going to receive the value. And I need to add my bit value, which is what's going to send the value. Now I want to go ahead and subscribe to these two. And now I'm going to go ahead and actually open up the I/O monitor so you can see how this behaves while we're looking at it. And I'm just going to go select my echo device. And for my test client, I need to write. I need to write to this item, so make sure I've got my bit selected. Right. I need to write either a 1 or a 0. So I'm going to write a value of 1 to our Boolean bit item. And apply that. And notice that for our data item, we get a value of on, which means that our translation is working as it should. If I go back in here and I write a 0, we can test the other translation, and we get a value of off. So I know that my translation is working correctly, and if I use this with an actual device, it would work properly. And I didn't have that played, so it didn't do that. So I'm going to do that. It didn't capture that, so I'm going to do that one more time. Notice this is the request, and this is actually the echoed back request. Since it's green, that means our response message parsed that correctly, and that's why we ended up with correct value here. So I mean, this is a simple example. The echo device is very useful for testing translations, like I've just shown you. You can use this to test EDCs. I use it all the time to test out EDCs and determine which exact EDC with formatting I'm going to need for a protocol. Or you can really use it anytime you have sample data and you want to test out how OmniServer is going to process that data in a response.